Hello, I'm looking at a problem from the chi-square test for an association between two variables. So this is section 7.2 in the Lock 5 textbook, second edition, and I'm going to look at homework question 7.31 from that section. So this is the section we're using a chi-square statistic to test whether there's an association between two categorical variables. So in this video, I'm just going to go ahead and compute the actual data using StatKey. But we've got two categorical variables right here. One variable is what group do you belong into? Group 1, Group 2, Group 3. And the second categorical variable is some question that has a yes or no answer. So do you answer yes or no? And for this problem, we're going to use this two-way table. I'm going to show you how to enter this into StatKey and how to compute using StatKey the expected count for each cell. And there are 6 cells. We're going to ignore the totals and the labels. 6 cells in this two-way table. And we want to compute the contribution for the chi-square statistic for that cell. We're going to look at group 3 and yes. So we're going to focus on the third row, first column. Okay, the first thing we want to do is enter this data into StatKey. So going over StatKey, this is the more advanced randomization tests, and we're looking at chi-square goodness of fit. We're looking at chi-square test for association. So section 7.1 and 7.2. All right, I'm going to click that, and there's a prepackaged data in here. So I want to edit data. So make sure to click on, make sure to click on the edit data button. Make this a little bigger, easier to see. All right, and I'm going to delete everything but that blank. I want to keep that blank there. And basically, I'm going to make this match up with this two-way table. So the first row is just yes or no, the two options on that first categorical variable. And then I have group 1, group 2, group 3. So I'm going to make this table in here, just separate the cells with commas. So group 1, yes and no was 56 yes, 44 no. I'm going to type 56, 44. For group 2, 132 and 68. 132 and 68. And lastly, group 3 is going to be 72 and 28. 72, 28. So if you're working at home, make sure this matches up. Group 1, group 2, group 3. And make sure to separate all of the group names with commas. Otherwise, it'll think these 1, 2, and 3 is part of the data, which is not. Those are just the 3 options for the 3 groups. Click OK. And here it'll give you the original sample on the right, and it gives you the totals. So if you have the totals, 100, 200, 100, 400, that should match up if we're given the totals here. That's just adding up each row and each column separately. And again, we wanted to know what is the expected value for group 3 to say yes, and then also the chi-square statistic for that cell. So to get that specificity in the data, in StatKey, click on Show Details. Make this a little bit bigger. And right here, in black is the observed. That's what you should have typed in. The green is the expected. So for group 3, the expected number of yeses should have been 65. There's more yeses than there should have been, assuming there's 0 relationship between these two variables, the yes or no in the 3 groups. And the contribution to chi-squared is 0.754. So the textbook goes over how to compute these two numbers by hand. I would say it's not difficult, but it is fairly tedious. And you will have access to StatKey on the test, so you only have to use the software. But if you like to see how things are done by hand, I suggest you read through the textbook, go over a couple examples. As I said, it's not difficult, just fairly tedious. And for the work solution, for group 3, it actually gives a formula. Group 3 row total times the yes column total divided by n to get the 65. And the textbook, I think, does a fairly good job explaining why we use this particular formula to get your expected counts. Again, it's based on the null hypothesis assumption that there is no association between these two categorical variables. And the contribution to the chi-square test statistic, it is your observed, the 72, minus your expected 65 and squared, because we don't care whether the observed is above or below the expected, just how different they are. So we square that, and then divided by the expected. And we get a 0.754 chi-square distribution. Or sorry, chi-square contribution. And notice right here, we get the total sum, chi-squared, is given in StatKey, 5.802. All that is adding up each of the individual chi-square contributions from each of these 6 cells. Add those 6 numbers up in blue here, and you get the 5.802.